Good evening, and welcome to Truth Report. I'm Alex Truth, and tonight we're pulling back the curtain on two stories that might seem unconnected at first glance, but together reveal a fascinating picture of where surveillance technology and massive corporate infrastructure investments are actually heading.
I'm Maya Clarity, and Alex, tonight's lineup is one of those shows where you have to connect the dots yourself, because nobody in power is going to connect them for you. We're looking at a breakthrough in particle tracking technology that has enormous implications for monitoring and surveillance, and a nearly $9 trillion investment by Hyundai Motor Group into an AI and robotics hub that will process staggering amounts of data. The question we're asking tonight: who is watching, what are they tracking, and who gave them permission?
That's the right question, Maya. Let's start with something that flew completely under the radar this week. A new paper published on AR14, reference number 2602.22257, titled Maximum Likelihood Particle Tracking in Turbulent Flows via Sparse Optimization. Now, I know that sounds like dense academic jargon, and it is, but stay with us, because what this research actually accomplishes has implications far beyond a physics laboratory.
Far beyond. And that's exactly why we're covering it. The mainstream press isn't going to touch a paper about Lagrangian particle tracking. But we will, because the technology that tracks particles in turbulent flows today tracks people in turbulent cities tomorrow. That's not speculation. That's the history of surveillance technology in a single sentence.
So let's break this down. Let's get into what this research actually says and why it matters. According to the paper published on AR14 this week, researchers have developed a new method for tracking particles moving through turbulent fluid flows. Now, here's the core problem they were solving. When you have particles moving through chaotic, turbulent environments, their positions are inherently noisy. You're dealing with imprecise measurements. And the accelerations these particles experience are extreme and intermittent, meaning they don't follow nice, predictable Gaussian distributions. Instead, you get what physicists call heavy-tailed probability density functions. In plain language, the movements are wild, unpredictable, and very hard to filter out from background noise.
And that's the critical technical point here, Alex. Existing filtering techniques, things like Gaussian kernels and penalized B-spline methods, they struggle with this kind of data. They were designed for well-behaved signals. They smooth things out, but in doing so, they lose the very extreme events that matter most. If a particle suddenly accelerates violently, the old methods would actually sand down that spike, treating it as noise rather than signal. This new approach using maximum likelihood estimation combined with sparse optimization is fundamentally different. It preserves those extreme events while still cleaning up genuine noise.
And that's a game changer. Think about what that means in practical terms. You can now track objects through chaotic, messy environments with far greater accuracy, and you don't have to sacrifice your ability to detect sudden, unexpected movements. The researchers are applying this to fluid dynamics, tracking particles in turbulence. But the mathematical framework is transferable. It doesn't care whether it's tracking a particle in a wind tunnel or a person in a crowd.
That's the dual-use nature of so much fundamental research, and it's something we rarely talk about honestly. The paper itself is legitimate physics research. The scientists involved are solving a real problem in fluid dynamics that has applications in engineering, meteorology, oceanography. But the algorithmic breakthroughs, the ability to track objects through noisy, chaotic environments while preserving detection of sudden anomalous movements, that is precisely the capability that defense agencies and surveillance companies have been pursuing for years.
Let's talk about the specific technical innovation here, because it matters. The sparse optimization component is key. Traditional tracking methods use dense filtering, processing every data point equally. Sparse optimization is selective. It identifies and preserves the most important signals, the outliers, the sudden changes, while efficiently compressing or discarding redundant information. In surveillance terms, that translates to a system that can monitor vast amounts of data but immediately flag anomalous behavior without drowning in false positives.
And the maximum likelihood framework means the system is constantly updating its statistical model of what normal looks like. It's learning the baseline in real time and then identifying deviations from that baseline with mathematical precision. Apply that to foot traffic in a city, to vehicle movements on a highway, to communications patterns in a network, and you have a surveillance tool of extraordinary power and subtlety.
Now, I want to be clear. We are not accusing these researchers of building surveillance tools. They're doing physics. But the history of technology tells us that breakthroughs in tracking and filtering don't stay in the laboratory. GPS was a military technology. The internet was a defense project. Facial recognition grew out of pattern recognition research. The pipeline from academic paper to deployed surveillance system is well documented, and it's faster than ever.
And here's what should concern everyone. This kind of research is typically funded by grants that come with few strings attached regarding downstream applications. Once the paper is published and the methods are public, any defense contractor, any intelligence agency, any private surveillance firm can implement these algorithms. There's no regulatory framework that governs the transfer of mathematical techniques from fluid dynamics to crowd surveillance. It's a blind spot in our oversight, and it's a big one.
The heavy-tailed distribution problem they solve is particularly relevant. In surveillance contexts, the events you most want to detect, a person suddenly changing direction, a vehicle deviating from its route, an unusual gathering forming, these are precisely the heavy-tailed events that Gaussian filters miss. This research cracks that problem wide open. It gives you the mathematical tools to detect exactly those anomalous behaviors in real time, in messy, real-world data.
And the scalability is what makes it truly concerning from a civil liberties perspective. Sparse optimization is computationally efficient by design. It doesn't require processing every data point at full resolution. It's smart about where it allocates computational resources. That means it can scale to massive datasets, exactly the kind you'd get from citywide camera networks, cellular location data, or Internet of Things sensor grids. You don't need a supercomputer. You need clever algorithms. And this paper just provided some very clever algorithms.
So who benefits and who loses here? The immediate beneficiaries are researchers in fluid dynamics, no question. Better particle tracking means better understanding of turbulence, which has real applications in aerospace engineering, climate modeling, and industrial processes. But the secondary beneficiaries, the ones who don't show up in the acknowledgement section, are the entities with the infrastructure and motivation to apply these techniques to human tracking. Defense agencies, intelligence services, and the growing private surveillance industry.
And who loses? Ordinary people who assume that moving through a chaotic urban environment provides some degree of anonymity through obscurity. The assumption that a crowd makes you hard to track. That assumption gets weaker every time a paper like this comes out. The math that separates signal from noise in a turbulent fluid is the same math that separates your movements from background noise in a busy city. And now that math just got significantly better.
This connects to a broader pattern we've been tracking on this show, which is the accelerating convergence between academic research and surveillance capability. The funding structures, the publication norms, the lack of dual-use oversight for mathematical and algorithmic research, all of it creates a pipeline that operates in plain sight but receives almost no public scrutiny. This paper is one example. There are dozens published every month.
And that brings us perfectly to our second story tonight, Alex, because if the first story is about the algorithms that make surveillance smarter, the second story is about the infrastructure that makes it bigger. Much, much bigger.
That's right. Let's turn to South Korea, where Hyundai Motor Group just announced plans that should have everyone paying very close attention. According to reporting from CleanTechnica, Hyundai has signed a memorandum of understanding with the Korean government and Jeonbuk state to invest nearly 9 trillion Korean won, that's approximately $6.5 billion, in the Simanjeom area of Gunsan City, with construction starting this year, in 2026.
And the scale of this project is breathtaking. This isn't a factory expansion. This is what Hyundai is calling an innovation hub, and it has 3 pillars: robotics, artificial intelligence, and hydrogen energy. Now, all 3 of those sound like benign, forward-looking technology investments. And in isolation, some of them are. But let's look at what's actually being built and what it means for surveillance infrastructure, because there's a component of this project that deserves far more scrutiny than it's getting.
The centerpiece of the AI component is a massive data center. According to the announcement, this facility will be dedicated to processing and storing critical data for what Hyundai calls physical AI implementation in autonomous driving. Let's unpack that phrase, because it's doing a lot of work. Physical AI means artificial intelligence that operates in the real world, on real objects, in real environments. And autonomous driving is the flagship application, sure. But the infrastructure required to process and store the data for autonomous driving is the same infrastructure that processes and stores surveillance data. You can't build one without building the other.
That's the key insight. An autonomous vehicle doesn't just drive itself. It continuously maps its environment. It identifies pedestrians, cyclists, other vehicles. It reads license plates, recognizes traffic signs, and increasingly, it recognizes faces. Every autonomous vehicle is a mobile surveillance platform generating terabytes of data. And all of that data has to go somewhere. It has to be processed, stored, analyzed. That's what this data center is for. Hyundai is building the nervous system for a fleet of autonomous sensors that happen to also be cars.
And the government partnership here is crucial. This isn't a purely private investment. The Korean government is a co-signatory on this MOU. Public funds and public land in the Simanjium reclamation area are being allocated for this project. That means the government has a seat at the table when it comes to data governance, and historically, when governments help fund data infrastructure, they also negotiate access to the data that flows through it. We've seen this pattern in China with their smart city initiatives, in the United States with the relationship between tech companies and intelligence agencies, and now we're seeing it in South Korea.
The robotics component adds another layer. Hyundai has been aggressively expanding into robotics through its acquisition of Boston Dynamics. When you combine autonomous vehicles mapping every street, a massive data center processing that information, and a robotics program that is developing machines capable of operating in human environments, you have the building blocks of a comprehensive physical surveillance and response infrastructure. That's not conspiracy thinking. That's reading the corporate strategy documents and connecting the stated capabilities.
Let's talk numbers, because the scale matters. 9 trillion won is an enormous investment, one of the largest single-site technology investments in Korean history. The Simanjium area is a massive reclaimed land zone on Korea's west coast, and Hyundai is essentially building a small city there dedicated to AI, robotics, and energy. The hydrogen energy component, which sounds green and clean, is partly about powering this enormous data infrastructure. Data centers consume staggering amounts of electricity. Hydrogen fuel cells are one way to power them without relying entirely on the grid. So even the clean energy story is, at its core, an enabling technology for the data processing capability.
And look at the timing. This announcement comes as South Korea is positioning itself in the global AI race alongside the United States, China, and the European Union. The Korean government has been explicit about wanting to be a leader in AI and autonomous systems. Public statements from Korean officials frame this as economic competitiveness, job creation, industrial policy. And some of it genuinely is. But embedded within every national AI strategy is a surveillance component, because the data collection that powers commercial AI is indistinguishable from the data collection that powers state surveillance. It's the same cameras, the same sensors, the same data centers, the same algorithms.
Hyundai's stated vision is what they call advancing Korea's transition to a robotics, AI-driven, and energy-centric future through transformative projects. That language, transformative projects, is worth dwelling on. Transformation means fundamentally changing the relationship between technology and daily life. When every vehicle is autonomous and connected, when robots operate in public and private spaces, when a centralized data center processes all of that information, the transformation isn't just economic. It's a transformation in the balance of power between institutions and individuals.
And the MAU structure is significant. A memorandum of understanding between a corporate conglomerate and a national government is not a casual agreement. It implies shared objectives, coordinated planning, and mutual obligations. What are those obligations? What data sharing agreements are embedded in this partnership? What access does the Korean government have to the data processed in Hyundai's facilities? These are questions that should be asked and answered publicly, before 9 trillion won is spent and the infrastructure is operational. Because once it's built, the surveillance capability exists whether or not anyone originally intended to use it that way.
Let's also consider the geopolitical dimension. South Korea sits in one of the most strategically sensitive regions on Earth, bordered by North Korea, within close proximity to China and Japan, and hosting a major U.S. military presence. A massive AI data processing center in this location isn't just a commercial facility. It's a strategic asset. And strategic assets attract strategic interest from every intelligence agency in the region. The data flowing through Hyundai's hub won't just be about autonomous driving routes. It will be a comprehensive, real-time map of movement patterns, infrastructure usage, and human activity across South Korea and potentially beyond.
And who benefits from this arrangement? Hyundai benefits from government support, land access, and favorable regulatory treatment. The Korean government benefits from technological prestige, job creation, and, crucially, access to a national-scale data infrastructure. Defense and intelligence agencies benefit from capabilities that would be politically impossible to build as explicitly military or surveillance projects but are perfectly acceptable when framed as autonomous driving research. The losers, as usual, are ordinary citizens whose movements, patterns, and behaviors will be continuously captured, processed, and stored by systems they never consented to and may never fully understand.
This is where the two stories we've covered tonight converge, Maya, and this is the pattern we need the audience to see. Story 1 gives us the algorithms, the mathematical tools to track objects through chaotic environments with unprecedented precision, to separate signal from noise, to detect anomalous behavior in real time. Story 2 gives us the infrastructure, the data centers, the sensor networks disguised as autonomous vehicles, the government-corporate partnerships that ensure the data flows to those with the power to act on it.
Exactly right, Alex. And this convergence is happening everywhere, not just in South Korea. We're watching a global build-out of what amounts to a comprehensive surveillance infrastructure, but it's never called that. It's called autonomous driving. It's called smart cities. It's called fluid dynamics research. It's called innovation hubs. Every individual piece sounds reasonable, even exciting. But when you assemble the pieces, the picture that emerges is one of pervasive, persistent monitoring of human activity at a scale that would have been unimaginable 20 years ago.
And the acceleration is what concerns me most. That particle tracking paper represents an incremental but real advance in the algorithmic capability to monitor complex environments. Hyundai's investment represents a massive expansion in the physical infrastructure to collect and process data. These advances are happening simultaneously, across multiple countries, across multiple sectors, and there is no coordinating body, no regulatory framework, no democratic process governing how they interact. The algorithms improve. The infrastructure expands. And nobody is asking the public whether this is the world they want to live in.
The funding structures guarantee this trajectory continues. Academic researchers are incentivized to publish breakthroughs that attract grants, and defense-adjacent applications attract the most funding. Corporations are incentivized to build data infrastructure because data is the most valuable commodity of the 21st century. Governments are incentivized to partner with both because surveillance capability is power, and no government voluntarily surrenders the possibility of more power. Every actor in this system is behaving rationally according to their own incentives, and the result is a surveillance apparatus that nobody specifically designed but everybody is building.
Let's talk about what meaningful oversight would look like, because we don't just identify problems on this show, we push for solutions. First, dual-use research oversight needs to extend to mathematical and algorithmic research, not just biological and nuclear research. When a paper demonstrates a capability that has obvious surveillance applications, there should be a review process that at minimum requires the researchers to acknowledge those applications and consider mitigation strategies. This isn't about censoring science. It's about responsible disclosure, the same principle we already apply to cybersecurity research.
Second, government-corporate partnerships like the Hyundai Mao need transparency requirements built in from the start. What data will be collected? Who has access? What are the retention policies? What are the civil liberties safeguards? These questions should be answered in public, debated in legislatures, and subject to independent oversight before the concrete is poured and the servers are racked. Once the infrastructure exists, the political will to constrain its use evaporates. We have seen this happen with every major surveillance system in history, from CCTV networks to the NSA's bulk collection programs.
Third, and this is the hardest one, we need to have an honest public conversation about the fact that autonomous vehicles are surveillance platforms. Every self-driving car is a rolling sensor array that maps its environment continuously. When millions of them are on the road, connected to centralized data centers, they constitute the most comprehensive surveillance network ever built. And it's being built with consumer dollars, marketed as convenience, and rolled out without anything resembling informed consent from the public whose lives it will monitor.
The technology itself is not the enemy. Better particle tracking algorithms could improve weather forecasting and save lives. Autonomous vehicles could reduce traffic fatalities. Hydrogen energy could help address climate change. Robotics could assist elderly and disabled people. These are genuinely valuable applications. But valuable applications don't exempt technology from democratic oversight. The same nuclear physics that powers hospitals also powers weapons. The same algorithms that track particles also track people. We have to be mature enough as a society to embrace the benefits while constraining the risks, and right now, we are not even having that conversation.
And that conversation is made harder by the way these stories are covered in the mainstream press. The particle tracking paper gets covered, if at all, as a cool physics breakthrough. Hyundai's investment gets covered as an economic development story, jobs and innovation. Nobody connects the algorithmic capability to the physical infrastructure to the surveillance implications. That's not an accident. It's the natural result of a media ecosystem that covers technology as a consumer beat rather than a power beat. Technology is about power, who has it, who wants it, and how it's exercised over the rest of us.
And the international dimension makes this even more urgent. When South Korea builds a massive AI data center, it's not operating in isolation. It's part of a global competition in which every major power is racing to build the most comprehensive data infrastructure. The United States, China, the European Union, India, Japan, all of them are making similar investments. The competitive pressure means that no country wants to be the one that slows down for democratic deliberation. The race dynamic actively suppresses the kind of careful oversight that these technologies demand. And ordinary people in every one of these countries are the ones whose privacy and autonomy are at stake.
So here's where we stand tonight. The math is getting better at tracking objects through chaos. The infrastructure is getting bigger, processing more data, covering more ground. The partnerships between governments and corporations are getting deeper, with fewer transparency requirements and more shared incentives. And the public conversation about what all of this means for individual freedom and democratic governance is barely happening. That's the pattern. That's what connects a physics paper on AR-14 to a $9 trillion investment in South Korea. They're different pieces of the same machine.
And that machine doesn't have an off switch, at least not one that's accessible to the public. It doesn't have a user agreement you can opt out of. It doesn't ask permission. It just grows, one algorithm at a time, one data center at a time, one government partnership at a time. And by the time most people realize what's been built, the cost of dismantling it will be orders of magnitude higher than the cost of building it. That's the asymmetry that makes this so dangerous. Building surveillance infrastructure is easy. Unbuilding it is nearly impossible.
That's why we cover these stories now, while they're still being built, while there's still time to demand transparency, accountability, and democratic control. Not after the fact. Not when the data has already been collected and the algorithms have already been deployed. Now. Because the window for meaningful public input on these systems is closing, and it's closing fast.
To our audience, I want to say this directly. Pay attention to the infrastructure being built around you. When you hear about autonomous driving investments, ask what happens to the data. When you read about breakthroughs in tracking and filtering algorithms, ask who else might use them. When your government signs partnerships with technology companies, ask what's in the agreement. These aren't paranoid questions. They're the basic questions that citizens in a democracy are supposed to ask. And the fact that so few people are asking them is exactly what makes the answers so important.
Before we go tonight, I want to remind everyone that the sources for everything we've discussed are publicly available. The particle tracking paper is on AR-14, reference 2602.22257. Hyundai's investment was reported by CleanTechnica and confirmed through the company's own announcements. We don't deal in rumors or speculation on this show. We deal in documented facts and their documented implications. Read the sources. Draw your own conclusions. And then hold the powerful accountable for theirs.
That's the Truth Report difference. We read the papers. We follow the money. We connect the dots. And we tell you what we find, whether it's comfortable or not. Because the truth doesn't require your comfort. It just requires your attention.
That's our show for tonight. I'm Alex Truth. Remember, the most dangerous surveillance system is the one you've been convinced is something else. A car. A physics experiment. An innovation hub. Look closer.
And I'm Maya Clarity. We'll be back next time with more stories the powerful would prefer you didn't hear. Until then, stay informed, stay skeptical, and stay free. Good night.